Okay, ladies and gentlemen, IB year number 2, welcome. Welcome to the video. I'm actually filming this video a day early because tomorrow I'm going to have Zoom meetings. I'd rather do the video early about human evolution for you guys. So you're going to see that I'm wearing something much different than I'm going to be wearing tomorrow. Anyway, I hope you guys are doing well wherever you are in Los Angeles or around the world. Today is a very special lesson. It's not technically a part of the IB curriculum, but I wanted to include it because it's really great learning. All this talk about evolutionary theory, cladistics, natural selection, and we have not yet applied that directly to human beings yet. So human beings are a part of nature. We're not any more special in nature than anything else. We must have gone through some kind of natural selection process as well. So how did that happen? We're also going to discuss all kinds of controversies surrounding human evolution since the idea even came about. And so today is a really exciting lesson. I'm stoked to get going. Let's just get started. So here we go. I'm going to share my screen. I'm going to show you where we are in our bills. Looks something like this. Okay, we're on page 38 and page 39. So on page 39, the title is Laetoli Footprint. And on page 38, the title is Human Evolution. Now, the goal of the day is very simple, just to understand human evolution in broad strokes. We're not going to go into the really nitty-gritty, but just to understand what it is conceptually. And then we're going to put the explanation over here on page 39, and then our brain jog is going to be on page 38. Pretty simple, I think. I'm going to stop that share. I'm going to show you the agenda for today. It looks something like this. That's not it. That's not what I want. That's for a different class. I want, which one do I want? I think I want this one. No, it's the same one. Ugh. Hold on. Okay, third time's the charm. Here we go. All right, here's the agenda for today. Number 1 is brain jog number 12 on evidence again, page 38. Number 2 is I'm going to show you a video of one of the most famous discoveries in human evolution, the video about a skeleton named Lucy. And then number 3 is I'm going to show you a human skull activity. Okay, pause for a second. Let me explain what this is. Normally in a class, I have a bunch of skulls mixed up on pieces of paper, and you're supposed to put the skulls in the right order, okay? That order being the order of human evolution. Obviously, we can't do that. We're not in a classroom, so I'm just going to give the skulls to you in the correct order. What you have to do is you have to write a sentence about each skull, make it a paragraph about each skull, explaining how the characteristics of the skull are different. For example, how is the brow different from the other skulls? What about the actual cranium section where the brain is? And what about the jaw? So those 3 regions I want you to take a look at. There are other things you can see, but again, the brow, the cranium, and the jaw. Write me a small paragraph for each skull explaining how those things changed over time. Okay, back to the agenda. Number 4 is I'm going to give to you a human evolution explanation in just a second. And then number 5 is I'm going to show you a video about the discovery of Australopithecus sediba. Sediba is another common ancestor of the modern Homo sapiens, and the way it was discovered is quite interesting. So it's like a half-hour video. It's pretty cool. You can just have it in the background and listen to what it is. That's the agenda. I'm gonna stop that share. And I'm going to start the lesson. What do you say? Okay, here we go. Topic, human evolution. How did modern Homo sapiens evolve from ape-like common ancestors? Is it true to say that the apes in the zoo, like the gorilla and the orangutan and the chimpanzee are just are those modern apes common ancestors of the human? Did humans just emerge from those modern species? We're going to address that today. And finally, we're also going to address how these cartoons of human evolution, while cute, is not the full picture. So what this is really kind of implying to people is that it kind of looks like human beings evolved from the modern monkey. And that's not true. Human beings didn't evolve from the modern monkey, and we're going to address that as well. So I'm going to stop that share. And I'm going to zip over to my handy dandy document camera. It looks something like this. Okay, blank sheet of paper. Let's begin. Take your markers out. You're going to need those, obviously your bill and your pens as well. This is on human evolution. As I'm writing this down, it might be a good chance for me to tell you that all of this stuff will actually be on the exam next week. So I have included it on your exam as well, because why not, right? It's good learning. You guys are IB cohort number 6. You will always and forever be my favorite. Cohort number 6, you can take that to the bank. Okay, first thing I'm going to do is I'm going to draw a timeline. I'm not that big a fan of timelines, but they do the trick. And I'm going to put 6 tick marks. Hey, not bad, huh? Okay. So what I'm going to do is over here is further back in time, and over here is near the present day. So I'm going to put 0 over here, and I'm going to put 8 over here. And I'm going to put 7, 6, 5, 4, 3, 2, and 1. And just so you guys know, these are not like 8 years, 7 years, 6 years. We're talking million years ago, abbreviated MYA, million years ago. Okay, we already kind of know the end of the story, or at least up to this point. We know that 0 years ago is the present day, and that's where we are. And we know at this point that the Homo sapiens have to be on this side of the page. So the question now becomes, well, if we trace back human evolution, what exactly have we discovered to suggest that we evolved from some kind of ape-like hominid? Okay. Well, let me present to you the evidence, and I'm going to show you what exactly we have found and all the cool, interesting things that come from that. Okay. The oldest fossil that we have ever found of an ancient hominid that's related to human beings is called Sahelanthropus cadensis. The T here is silent, cadensis. Sahelanthropus cadensis. Sahel, I believe, is Swahili. It's a word that comes from the region where the fossil was found. Okay. This particular species of ancient hominid walked the earth 6 to 7 million years ago. We talked before about the power of radiometric dating. We can actually very accurately determine the age of the rocks around which the bones were found. So it's safe to deduce then that the bones might be that age where the rocks were surrounding it. Now, what's interesting about Sahelanthropus is that the ancient hominids appeared to not spend all their time on 2 legs. And the reason we know that is we can look at their knee bones. So the bones of the modern human, the knee bones of the modern human suggest that we spend the majority of our time on 2 legs. But the knee bones of these older ancient hominids don't really look like that. They're much more angled. So it's safe to deduce then that they spent most of their time not on two legs, maybe on four legs. But this one is quite interesting because the bone structure indicates to us that they did spend some time upright walking. And when I say sometimes, I mean semi-bipedal. Bipedal meaning two, well, pedal meaning feet, and then bi meaning two, so bipedal, 2 feet. And what's also interesting about Sahelanthropus cadensis is that we look at the teeth, and the teeth tell us a lot about what kind of diet this ancient species had. And what we see is that we see a minimization, a smaller canine tooth. Now, the canine teeth are your vampire teeth. You come right here. You come down here as well. You have 4 of them. And a smaller canine indicates a change in the diet. Now, what might be helpful here is to show you what an artist's rendition of Sahelanthropus cadensis might have looked like. Again, we don't have digital images of what they looked like because we didn't have that kind of technology 7 million years ago. But artists have done a pretty good job at showing us what they might look like. And when I say artists, I mean artists, not like your run-of-the-mill Instagram artist. I'm talking about the artists employed by, this is from the Smithsonian Museum of Natural History. I love museums of natural history. I think they're so darn cool. So if you look at the tree of human evolution, they have a really awesome graphic that you can take a look at. And if you click on Sahelanthropus cadensis, see, it's the oldest fossil we have found. And if you click on it, then there appears a artist rendition of that. And as you can see, it was found, there's some information here that you can see, da, 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 da. And then you can even read down here. I don't know why it's cut off on your computer. It shouldn't be. It's pretty cool. So again, see, like this is the timeline that we drew down here, and this is as old as we have found so far. They're going to continue updating it, and this oldest one we found so far. Okay. On the timeline, I'm actually going to put where we found how old these fossils are. So we're going to say 7 to 6 million years ago would be Sahelanthropus cadensis. The next highlight in human evolution I'd like to bring to your attention is the species that we have nicknamed the Lucy species. This species is called Australopithecus afarensis. Oh boy, these are mouthfuls, huh? Sahelanthropus cadensis Australopithecus afarensis. These are fun words to say, so I really encourage you to try them out on your own. Sahelanthropus cadensis Australopithecus afarensis. These are 2 vocab words. Now, in the video that I hope you have seen before, this video, it goes through the discovery of Lucy. It was named Lucy because at the time where they were celebrating the discovery, they were listening to the Beatles song Lucy and the Stars with Diamonds. So that's why they named her Lucy. Lucy, if you did the radiometric dating, seems to have lived 3.8 3.84 to 2.95 million years ago. So I've skipped a whole bunch of million years, right? I only went to about 3.84, which is here, to about 2.95, which we're going to estimate is right there. Obviously, there's a big jump, and there are other species in between, but let's just leave it at that for now. You can take a look at the Smithsonian website to check out more. Okay, here's what's interesting about Lucy. Her arm bones are much thicker than the arm bones of her predecessors. She has thicker cortical bones. Okay, I'm going to do my best to kind of visually draw this for you. If it's confusing, please ask me for clarification. All right, you take your arm, this part right here, from wrist to elbow, and you remove the bones from it. What you'll see is you have one bone that looks like this. Let's draw it like that. This could be your radius, and your ulna looks something like this. Looks a bit like a wrench. So this is radius, and this is ulna. And what I'm going to do is I'm going to cut across it. I'm going to give it a cross section, okay? So I'm going to cut it like this, as you can see, like that. And then when I cut it, what you'll find is that the bone is hollow on the inside. Like this. So there's some hollowness where the bone marrow is, and then there's some bone on the outside like this. All right. What's interesting about Lucy is that this region of bone is much thicker than the fossils we have found of species before Australopithecus afarensis. Okay, what does this suggest? This suggests their arms were used for greater purposes than simply the ones before them. What do we use with arms? Used arms for many different purposes, such as tool making. Okay. There are a lot of interesting things about Lucy's skeleton, but I'm only pointing out one. The thickness in the cortical bones reveal to us that members of her species were using some kind of tool in order to build the bones of the arms. In order for a bone to build, you have to be using it in a particular way. So that was quite interesting, okay? It was also interesting how her knees were attached, how her jaw was attached, how big she was, how wide her rib cage was. There's a lot of interesting things about Australopithecus afarensis. Lucy was the first to be found. Since Lucy, there have been dozens of other skeletons from Australopithecus afarensis that have been found. So Lucy was the first. Sometimes we get evolution deniers and they say, well, you only found one. No, actually, we found plenty. Lucy was just the first. Okay. The third highlight in human evolution that I would like to show you all is a new genus of ancient hominids. Homo erectus. Pause for laughter. Pause for laughter. Okay. Yes, erectus sounds like the word erection, but erectus actually means to stand up, right? To erect a building. So Homo erectus means a fully standing up ancient hominid. You know what might be a good thing to mention right now? Brief tangent. This word hominid that I'm using, hominid, Hominid, this is referring to species that are somewhere in between a modern ape and a modern human. So when we find these skeletons, not only can we determine the age, but we also can determine that this thing absolutely did not belong to a modern ape, and it did not belong to a modern human. It was something in between a modern ape and a modern human. Okay, when it comes to common ancestry, that should make sense. I'm going to stop that share quickly, and I'm going to show you what artists think Lucy or her species looked like. We're going to go back to our, let's see, Australopithecus afarensis is right here. Let's check it out. There we are, Australopithecus afarensis. Stop that share. Okay, back here. From the name, we have named it based on the evidence that we found. So we found that their knee joints were much more linear than the knee joints of Australopithecus afarensis or Sahelanthropus cadensis. So the linearity of that knee joint suggests to us that Homo erectus walked on two legs. So this hominid was quite bipedal. The location of where we found the skeletons was quite interesting as well. There's evidence to suggest that these ancient hominids were using fire because we found them around potential fire pits, found evidence of that. It's quite interesting. What's also interesting is that there's evidence to suggest that these this species buried their dead, which actually is a really interesting behavior for any organism on the planet. You actually memorialize the people that came before you and then have died. And so that kind of behavior was very interesting to find. Another point is that there's evidence to suggest that these bands of species actually cared for members of their species who were old and sick. That's a very interesting behavior in nature as well. We have hospitals to take care of our old, our sick, people who are weak in that time of their life. And that's kind of unique. That's kind of unique in the big scheme of things, because in nature, if you're old and you're weak, you die or you're left behind. And so Homo erectus was displaying some very interesting behavior. We know this because there is hundreds of bones out there that reveal to us this was an older Homo erectus than this bone. Because as you get older, your bones change. And so the evidence of older individuals within that species reveals something about how they cared for their old and their weak. Next point. They are the longest lived species. And now I'm not saying that they lived for the longest, like they lived to 120 years per individual. I'm talking about their species walked the earth for much longer than our species did. Okay. So far in the story of human evolution, they are the ones that have survived the longest. They're no longer here, the species died out, but they spent the most time there. Now, when I say the most time, what do I mean? They walked the earth about 1.89 million years ago to 143,000 years ago. So let's put this on our timeline, shall we? 1.8 million, let's say 1.89 million is about right there, all the way to 140,000, so about right there. So even on our timeline, it has already surpassed Sahelanthropus cadensis and also Australopithecus afarensis. There's also evidence to suggest that Homo erectus were using a lot of tools that can be used to make fire or things that can supplement a fire. Homo erectus was quite fascinating. Let's take a look at what artists thought they might have looked like. Homo erectus, see how long this line is? Bubbing, looks something like that. Australopithecus afarensis. I'm sorry, that's not that's Homo erectus, my bad. This is Homo erectus. I showed you Australopithecus afarensis earlier. Stop that share. Okay, now we're getting to the more modern species, but I want to show you guys something before we move forward. This is not a stepwise movement in evolution. Again, evolutionary theory is not Pokemon. This is not Eevee. This is not Flareon. This is not whatever, okay? Let's do a 3. This is not Squirtle. This is not Wartortle. And this is not Blastoise, okay? It doesn't go 1, 2, 3 like that, which is kind of why I have a problem with that cartoon I showed you at the beginning of the video. It's a good start, but it doesn't tell you the whole picture. Don't think about it as a line. Think about it like a tree. A lot of the species of ancient hominids walked the earth at the same time. Okay? For instance, let's go back to our, sorry, I'm kind of flipping back and forth a lot here. Hopefully you're not getting dizzy. Flipping back to this Smithsonian, if you see there are tons of overlap. So even within the lifespan of Homo erectus, you have a little bit of Australopithecus sediba, which is what I'm going to show you later. Homo habilis was in there as well. Even Homo sapiens walked the earth at the same time as Homo erectus. The Neanderthals also walked the earth at the same time Homo erectus and Homo sapiens were on the earth. Can you imagine that? Can you imagine an entirely different species of hominid occupying a part of the earth somewhere? That'd be pretty neat, huh? Oh man, you're a Homo erectus? That's cool. I've never met one like that before. But they walk the earth at the same time. So don't think about this as a linear stepwise progression. Think about it like a tree with branches. Some branches die off, some branches survive. Okay, so let's talk about another branch that walked the earth but is no longer here. Homo, Neanderthalensis. Oh boy, these words are so cool. Neanderthalensis can be shortened and called the Neanderthals, sometimes the Neanderthals, but I like to say the Neanderthals because that's how I learned it. Okay, what's interesting about the Homo neanderthals is that what they have are very interesting noses. The nose does a lot of really cool things for us that we kind of take for granted. One of those things is humidifying the air. We live in Southern California. It's very dry here, so there's not a lot of moisture in the air. If you want to feel some humid air, go to Florida or Asia. Well, parts of Asia, tropical Asia. Okay. The nose for Homo neanderthalensis appears to reveal that they began to humidify the air. There's also abundant evidence to suggest that there is creation of symbolic behavior. And one of the most symbolic behaviors that we do is language. So we can use our vocal cords in a way where we can shape the sounds that come out of our mouth to communicate something to somebody else. That's pretty cool. When you think about it, language is a creation, okay? It's not born into us like fingers and toes. Instead, it's created by the culture around us. So what we've done is we have morphed the symbolic language into we have morphed the symbolic behavior into some kind of communication form. Even the fact that I'm writing these scribbles on the page is communicating something to you. It's pretty neat. Symbolic behavior. The Neanderthals occupied the Earth 400,000 years ago to about 40,000 years ago. And 40,000 years ago in the big scheme of things, class, it's not that long ago. Most of the Neanderthals occupied Europe, and so there are Europeans out there that still possess a good amount of Neanderthal DNA. When that was discovered, oh boy, society had a field day with that. Okay, we'll talk about that in a minute. So let's try to put this on the timeline, shall we? Neanderthalensis 400,000 years ago, let's say, is right here, to 40,000 years ago. We're getting really, really close to the present now. But do you see how there's kind of some overlap between Erectus and Neanderthalensis? The Neanderthals were the ones that gave us those magnificent cave drawings, some of which you can still go see, I believe, or they have some kind of replica somewhere. Um, you know, there's a misconception out there that ancient hominid species spent a lot of time in caves, so they're called cavemen. Nah, not really. Sometimes they go in caves and find shelter, but for the most part, they were nomadic. They would walk around and explore places. The Neanderthals died off. At the same time, the Neanderthals, Homo erectus, they were competing with another hominid species, Homo sapiens. And Homo sapiens, man, we are a wicked kind of species, and I'll tell you why in a second. The first indication of Homo sapiens being on the planet about 200,000 years ago. Homo sapiens has some very interesting adaptations. We have things like opposable thumbs. Our cranium is much different from the other ancient hominids. We also have this very curious mind. That allowed us to create all kinds of new innovations. One of the greatest innovations, the inventions we have ever done. Language is a great invention, but another great invention was the domestication of crops. We pick the plants we like to eat, we put them in a farm, and we grow them. The creation of more specialized technology. Technology leads to urbanization. We created all kinds of things like religion to explain the world around us as best we can. And we can create large institutions that find truth in the universe. We can create scientific institutions. We wonder things like, what is the meaning of our existence here? Where as a species are we going to go? What do we believe in as a species? What are the values of humanity? Those sorts of things we don't have evidence of previous hominids thinking about. And Homo sapiens have been around pretty much like around here to the present day. Now, I am sure you guys have questions about this. Okay, there are a lot of questions about this, and it's not the full picture. And we honestly do not have time to give you the full picture in an hour. Okay, but if you're interested in learning about human evolution, there are all kinds of careers you can take to further investigate this topic. Anthropology is one. Paleontology is another. You can go archaeology. Those sorts of careers investigate human evolution as well. Okay. Maybe I'm going to end with this. Two things. Where did these hominid species come from? Simple question. The answer to that question lies in something we've already discussed before. Natural selection. Nature has decided which of the species will win out in the end. These four have been eliminated. Their species is gone. Homo sapiens are the only ones, the only hominids that still occupy the earth. And it could be for a lot of reasons. It could be that it could be a disease that wiped out these species. It could be severe climate change that wiped out the species, which is why climate change right now is so injurious to our species, because it could wipe us out. Who knows? Another point I'd like to make about this is that human evolution has been such a controversial topic. And that's why I think some science teachers just avoid it altogether. It's controversial because there are some people, non-scientists and some scientists also, that claim one particular group of people, of Homo sapiens, are more evolved than another group of people. And that leads to all kinds of things like social Darwinism, racial stratification, social hierarchies, all that kind of nonsense. But I really, really like to reiterate, every human being on this planet belongs to the same species of Homo sapiens. We're all on the same plane of human evolution. No one is more evolved than anybody else. Okay. So I'm going to stop that share. I'm almost at maybe 40 minutes of the video, but I hope that was a good introduction to human evolution. I'm going to end, I just thought about this. I'm going to end with the Smithsonian. As you can see, there's many, many more to investigate, all kinds of really cool things out there to look at. And down here, you can see the huge milestones in human evolution. Museum of Natural History, I think, is very credible. They take all their information from evidence that has been found. Sometimes these things will shift depending on new information, but this is the most accurate representation we have so far. So check it out. It's fun. It's fun to look at and explore. Okay, I'm going to stop that share. I think I'm done with this, and you guys will see this posted tomorrow. I think that's all I have to say. We are going to summarize on Zoom tomorrow, and then you guys will be ready for your exam. So I hope you enjoyed this bonus lesson. Sometimes I do it, some years I don't, depending on the circumstances. So I really hope it was helpful to you. Please check out a natural history museum, man. They're super interesting. That's it. Peace.